Okay, so we're working numbers 13 through 26. It's page 20. You do not have to watch this video if you don't have any questions on the homework. If there is a problem you don't know how to do, just fast forward to that problem, but you don't have to watch the whole video. Okay, so for number 13, how many terms is it? It's 3 terms. So it's going to be factoring a trinomial. We look at the leading coefficient. It's a 1. So to be able to factor a trinomial with a leading coefficient of 1, you just go straight to writing your answer, your 2 binomials, decide what the signs are going to be, and then find the factor pair that combines to give you your middle term, and that will be what you write in the last spots of each binomial. All right, so I just go straight to writing this. Oh, by the way, if you did learn about perfect square trinomials, this is a perfect square trinomial, so you can do that. Okay, so the factor pairs of 81 are 1 and 81. 2 won't go into it. 3 will go into it 27 times. 4 won't. 5 won't. 6, 7, 8. And then we know it's 9 times 9. Okay, this tells me that the signs are going to be the same and that they will both be negative. So I know whichever factor pair I use, that both of them are going to be negative. Now I look for the factor pair that combines to give me a negative 18, and it's the last one. All right, so what multiplies together to give you a t squared? T times t, and then this takes the last spot. Okay, you can check it by using FOIL. Multiply first terms, and then outer and inner, and then last terms. Okay, number 14, it's a trinomial, so we need to check the lead coefficient. The lead coefficient is a 1, so we're going to do the same thing. We're going to just go ahead and jump straight to writing our answer. What multiplies to give you an x squared? X times x does, so that goes in the first spot. Okay, then we list the factor pairs of 15. That's 1 and 15. 2 won't go into it, and then there's a 3 and a 5. This tells me that the signs are going to be different. This tells me that the larger number is going to be a negative. So whichever factor pair it is, I know that the larger number will be the negative, and I look for the factor pair that combines to give me the middle term of negative 2, and a positive 3 and a negative 5 do that. So I can go ahead and use that factor pair to write the last spots in the binomials. And you can check it using FOIL. Okay, number 15, we look at how many terms. It's got 4 terms. So automatically I know I'm going to go to checking it with grouping, factoring it with grouping. Group the first 2 together, group the last 2 together. Now, you should be pretty good at factoring by grouping, and you can look at this and tell that they don't have a greatest common factor in this first pair. The second pair has a greatest common factor of 2u. But you know that whenever you factor these out, that you should have 2 binomials that look the same. It's not going to happen here. So you have to be a little bit of a detective here. You need to look for the 2 terms that you can get a greatest common factor out of, and have binomials that look the same. So I can rewrite the order here. Now if I put 4u squared and then plus 2ux, I know that I could factor out a 2 and a u from these 2, but that probably isn't going to work because I can look at what's left and see, I don't think that's going to work. But if I take the 2u and put that next, and then I have the x and the 2ux. If I put it in this order, I know that whenever I factor it, I'll have 2 binomials that look the same. So I'm going to group the first 2 and the last 2. These have a 2u in common, and whenever I factor that out, I'll be left with 2u plus 1. These have an x in common, and whenever I factor that out, I'll be left with a 1 plus 2u, which is the same thing as 2u plus 1. So when I look at the first group after it's factored, and I look at the second group after it's factored, the binomials are the same. So I can factor out the binomial 2u plus 1 from the first group, and I'll be left with a 2u. Factor out the 2u plus 1 from the second group, and I'll be left with an x. Now, this one was difficult because you had to work with the order of the terms to be able to figure out how to graph it by grouping. So this was a hard problem. Okay, number 16. How many terms does it have? It has 3 terms, so it's a trinomial. So I'm going to check the leading coefficient. It's something other than 1. So the notes from post number 20 is what I'm going to use to factor this. You're going to multiply the first and the last number together and look at the factor pairs of that product, and the factor pair that combines to give you the middle number is what you're going to use to rewrite the middle term. All right, so I'm going to multiply the 4 and the understood 1 together. So 4 times 1 is 4. I need the factor pairs of 4. This tells me that the signs are going to be the same and that they're both going to be positive. So when I'm looking at the factor pairs, I know they'll both be positive, and I need to find a factor pair that will combine to give me a 2. Well, 1 plus 4 equals 5, and 2 plus 2 equals 4. So nothing combines to give me a 2, so I can't factor it that way. So this is prime. Can I see your cell phone? I need to know if this is prime or not. I don't want to stop the video and redo all this. So I'm going to have to cut this part out of the video, but second power plus 2CD plus C to the second power. Oh, I forgot to write the word factor. Factor. Go. That's not it.
Oh, this thing has a camera on it?
What? No. Why, like there's, what is he eating?
Something crunchy. I'm gonna guess plastic.
Oh crap, here, I don't know. Okay, I'm good.
Okay, get the answer for you?
No, I'm good. Okay, so I'm gonna start my video again. All right, Or since it's prime, that means that it is in factored form, so you could also just rewrite the problem as your answer. Okay, let's go to number 17 is a trinomial. And if you look, the leading coefficient, it's not in descending order. So I'm going to go ahead and rewrite this in descending order. Remember, descending order is whenever you look at the exponent of the variable, the largest exponent goes first, and then it goes in descending order. Now, whenever we go to factor this, the leading coefficient is 1, so you would go straight to writing the answer. And whenever you look, you have t to the third power. There is nothing times itself that you can multiply together to get t to the third. So actually, this is not factorable. So it is prime. And so you could write the answer as prime, or you could write the problem. Since it's in factored form, it can't be factored. All right. For number 18, it's a binomial. So if it's a binomial, you want to check for difference of squares. I can't take the square root of 8, so I know it's not a difference of squares yet, but let me see if there is a greatest common factor. And there is a greatest common factor of 8. So you can list the prime factors of both of these terms, and then you'll factor out the 8, and you'll get x squared minus 9 p squared. Now let's check and see if these are perfect squares. So can you take the square root of x squared? Yes. Can you take the square root of 9 evenly? Yes. Can you take the square root of p squared evenly? Yes. So now it is a difference, because it's subtraction, difference of 2 perfect squares. So I can go ahead and write the square root of the first term will go in the first spots. The square root of the last term goes in the last spots. And 1 will be plus and 1 will be minus. And don't forget to write the greatest common factor with the answer. Okay, number 19, it's a binomial, so we need to check for a difference of squares. Well, it's not a perfect square yet, but is there a greatest common factor? There is, it's 5. So I can look at, if I were to factor out a 5, or in other words, divide this by 5, I would get 4q squared. And then factoring out a 5 here, I would just be left with r squared. Now, is it a difference of squares? Well, can I take the square root of the 4 evenly? Yes. Can I take the square root of q squared evenly? Yes. And the square root of q squared is q. Can I take the square root of r squared evenly? Yes. All right, so I can go ahead and write my answer. Don't forget the greatest common factor of 5. Square root of the first term goes here. Square root of the last term goes here. 1 is a plus and 1 is a minus. All right, so this problem had 3 factors: a 5, a binomial, and another binomial. Okay, number 20, another binomial, so we need to check for a difference of squares. Is this a perfect square? No, I can't take the square root of 32, but let's check for a greatest common factor. So if you look at this, I know that they both have a greatest common factor of 2. So if I factor a 2 out of this, or in other words, it's just like dividing by 2, then I'm going to be left with a 16a squared. And then I factor a 2 out of this, I'll be left with a 25b squared. Now let's check for perfect squares. Can I take the square root of 16 and the a squared? Yes. Can I take the square root of 25 and the b squared? Yes. So I can go ahead and write my answer. Square root of the first term goes in the first spot. Square root of the last term goes in the last spot. 1 is a plus and 1 is a minus. If you can tell, I'm starting to skip a lot of steps because I'm hoping you're getting better at this. or quicker. Okay, number 21 is a trinomial. So we need to check the leading coefficient is not a 1. So I'm going to multiply these two numbers together and get 28. And then I'm going to look for some factor pairs that will add to give me or combine to give me the middle term. So I have 2. Will 3 go into that? No. Will 4 go into that? 4 times 7 is 28. 5 won't, 6 won't, and then we have a 7. Now let's check the signs. This tells me that the signs are going to be the same, and this tells me they're both going to be negative. So whichever factor pair I use, I know that both of the factors will be negative. I want the factor pair that combines to give me a negative 11. That's right here. So I'm going to use this to rewrite the middle term. Okay, so the first term is 7x squared. The middle term, instead of writing a minus 11x, I'm going to write a minus 4x and a minus 7x. So I haven't changed the value, I just wrote it in a different way. Okay, now I'm going to group the first two and the last two together, because now we have 4 terms. You factor it by grouping. The first group has an x in common, so we factor that out. The second group, I know whenever I factor it out, I need to have a 7x minus 4, so I need these signs to be different. So I'm going to factor out a negative 1. And when I do, that'll change the signs. And again, I've explained that on previous videos, so I'm hoping you just automatically understand that. All right, so now we look at the factored form of the first group, and I have the binomial 7x minus 4. In the second group, I have that same binomial, so these two groups actually have a 7x minus 4 in common, so I can factor out that whole binomial, and when I take it out of the first group, I'll be left with an x. When I take it out of the second group, I'll be left with a minus 1. Okay, so that's the answer to 21. Okay, 22, we have a binomial. So if you have a binomial, the only thing you need to check is for a difference of squares. Difference means subtraction. It is subtraction. Can you take the square root of the first term evenly? Yes. Can you take the square root of the second term evenly? Yes. All right, so we can go ahead and write our answer. Square root of the first term plus square root of the second term, and then same thing, but use a minus. Okay, number 23, it's 4 terms. So the only way to factor that is by grouping. So I'm going to group the first 2 together and the last 2 together, and whenever you do, make sure the sign in front of the term stays with the term. It's in the group. Okay, first group has an a in common, so I factor that out, and I'll be left with a d plus 3. Second group has a greatest common factor of d, but I also know that I'm going to need these both to be positive, so it'll look like this. So I'm going to factor out a negative d. Since I factored out the negative, or the negative 1, then that means these signs are going to be changed, and I'll have a d plus 3 left. Now, when I look at the factored form of the first group and the factored form of the second group, I see they both have the binomial d plus 3. So I'm going to factor out that whole binomial. When I take it out of the first group, I'm left with an a, and in the second group, I'm left with the minus d. Okay, number 24 is a binomial. So the only thing I'm going to check for is a difference of squares, or a greatest common factor, actually. They don't have anything in common, so there's no greatest common factor. This is not a difference. This is a sum of squares. We can't factor a sum of squares, so we are done. This is prime. Or you can just write the problem as your answer, since that is in factored form. It's a prime factor. Okay, number 25. What do they both, let's see, okay, so it's a trinomial, so I check the leading coefficient. The leading coefficient is not 1. There's not a greatest common factor, so I'm going to go ahead and multiply the first and the last number together, and then I'm gonna look for a factor pair that will combine to give me the middle term. 4 won't go into that, and then 5 times 6. This tells me that both signs are going to be the same, and this tells me that they will both be positive. So I know whatever factor pair I'm gonna pick, I know that both of them will be positive. So I need the factor pair that will combine to give me a 17, and that is 15, a positive 15 and a positive 2 gives me a positive 17. So I'm going to rewrite the middle term. Instead of writing as 17x, I'm gonna write that as 2x plus 15x. So I haven't changed the value, I just rewrote that. Now I have 4 terms. When you have 4 terms, you factor by grouping. So grouping the first 2 and the last 2. These both have an x in common, so that leaves me with a 5x plus 2. Okay, and I know this is gonna have to end up with 5x plus 2, so I'm gonna see, that makes it easier to see that it has a greatest common factor of 3, and I'll be left with a 5x plus 2. I'm running out of space there. Okay, so this is the factored form of the first group, factored form of the second group. They both have the same binomial, so I'm going to factor out the whole binomial. When I factor out this binomial, I'm left with an x. When I factor out that binomial, I'm left with a 3. So that's the answer. Okay, for number 26, first of all, it's a trinomial. The leading coefficient is not 1, okay? And these are big numbers, so I'm gonna go ahead and check for a greatest common factor. There is a greatest common factor of 2. So that means this is going to be a 25q squared minus 30q plus 9. Now, if you learned perfect square trinomials, this is a perfect square trinomial because the square root of the first term is 5q, square root of the last term is 3. 5 times 3 is 15, and 15 doubled gives you 30. So this is a perfect square trinomial. So you could just go straight to writing the answer. But if not, we have to multiply the first and the last term together. So that will be 25 times 9. That's 225. And I always think of quarters. 9 quarters is $2.25. So the factor pairs are 1 and 225. 2 won't go into it because it's not even. 2 plus 2 plus 5 is 9. 3 will go into 9. So I know 3 is going to go into that. 3 is going to go into that 75 times. Okay, will 4 go into that? No. Will 5? Yes, 5 will go into it 45 times. And I'm kind of, let's see. I know the middle term, I'm gonna have to rewrite it to give me 30, so that doesn't, so I'm gonna keep going. Will 6 go into this? No. Will 7, 8, 9, 10, 11, I'm going to get my calculator. 23, 49. Okay, and I'm just gonna go straight to, it is you check all the numbers, and then you end up with 15 times 15. Okay, so now this tells me the signs are going to be the same and that they will both be negative. So whichever pair it is, I know that both signs are going to be negative. I need the factor pair that rewrites to give me a negative 30. It's right here. So we have a 25q squared. Instead of writing a minus 30q, I'm going to write minus 15q and minus 15q because that is the same thing as negative 30q. So I haven't changed the value, I just rewrote the middle term. Okay, we're going to factor it by grouping now because it's 4 terms. These have a 5q in common, and then I'm going to be left with 5q minus 3. These have a 3 in common, and I need the signs to be different, so I'm going to factor out a negative 3. Factoring out the negative will change the signs. Okay, now I look at the factored form of the first group, the factored form of the second group. They both have the binomial 5q minus 3, so I'm going to factor out the whole binomial from the first group, and I'm left with a 5q. Factor out the whole binomial from the second group, and I'm left with a minus 3. Don't forget the greatest common factor. So this is your answer. And if you did it as a perfect square trinomial, you wouldn't have had to do any of this. You could also write it in a better way. Since both binomials are the same, I could write 5q minus 3 squared, because that's 5q minus 3 times 5q minus 3. Okay.